All right, so slope. How many of you remember rise over run? Raise your hand. Give me a thumbs down if you do not remember ever hearing rise over run. Okay, so we've at least all heard that. And so that's the basics of slope. This is the slope formula. And remember, the test for this unit is going to be open notes. So you have all these formulas. Just a quick thing to remember is positive slope goes up like this. So this is our positive slope line. The colors didn't overlap when we photocopied these, so you might want to like highlight or draw the line. Positive slope is if we're driving along it or we're walking, we'd be walking up. Negative slope is when we're going down. And so it's this one. And again, you're always coming from this side. And so if you're going downhill, it's negative slope. Zero slope is the one that goes straight across. We aren't going up, we aren't going down. It's just zero.
In 8th grade, my teacher, she like made a face to like show us how to like remember. And it was like a weird face. It
So,
like a clown.
Like a clown face? You did that? Yeah. You want to draw it and show it to me? Alright, and then undefined, this last one you guys didn't print out well, so right in there, undefined. If we can't define it, we can't walk on it.
It looks like this.
That's a pretty good one. Great, so let me see if I can copy it here so it's on the video. So you did negatives this way, positives this way, undefined is this way, and then 0. Does that help you remember it? That's a 0. If that helps you remember it, you can do it that way. Okay, so undefined is when we have the straight up and down like a wall that we can't walk on.
So yeah. Oh, that's supposed to.
Okay, can I move mine over yet? Not quite. Alright, give me thumbs up, medium down. How well you remember learning about parallel and perpendicular lines last year? It was covered last year. Okay, so we're pretty split there. This is something you will really use a lot here. So parallel lines is just they have the same slope. Really easy. Okay, so slope of 3, slope of 3, it's the same slope. Perpendicular lines, if we multiply the slopes, they will give us -1. Usually we define this as they just have opposite reciprocal slopes. And remember, as we were listing out the properties of quadrilaterals last class, we did a lot of, hey, these have parallel lines or they have perpendicular lines. So these are the things we're going to be proving is either parallel or perpendicular. So what would be the opposite reciprocal if I had 3/4? What would my perpendicular slope be? 4/3 in positive or negative?
Negative.
Yeah. So that's what it means by opposite reciprocal. What about 1/2? What would the opposite reciprocal of 1/2 be? Just -2, because technically it's 2 over 1, but that just simplifies to -2. So when you're finding slope, like here it just tells you the slopes, but let's make sure you remember how to count it out. You just find 2 points where it's clearly crossing through a corner. And then we count our rise and our run. So I usually count by doing little humps like this because it's easy for me to keep track. So 1, 2, 3 was my rise, and then my run was 1. What's your question? It's yeah, you flip it over and make it the opposite sign, so positive and negative. Alright, are you ready for the next part? A few people are still writing. So that's our basics of slope. Give me thumbs up, medium down. Do you remember distance formula?
Oh, y goes in for me.
This one right here.
Oh yeah.
Okay, so really big mix between up, down, and medium. So distance formula is really easy. You just plug in the points. So are these points x, x, y, y, or is it x, y, x, y? Yeah. So x always comes first. It's alphabetical. X. So this would be x1, y1, x2, y2. And so I'm just plugging it into the formula. So what is my x2 number? Oh, I need to call on people. All right. I'm going to call on desk numbers. Desk 29, which is Nick. Nick, what is x2 in example 1 here? -1. We got it. All right. Desk 8, which is Christian. What is our x1 here? 5. And so my formula is just x2 minus x1. So I do -1 minus 5 squared. Keep the plus sign. I'm just copying out the formula. And desk 2, which is Noe. What is our y1? Sorry, y2. Nine. And desk 18. What is our y1? Who's the desk 18? Yeah. Okay. So now the thing is, we could work this out by hand, or we can plug the whole thing into the calculator. So I'm just showing you how to do this, and a lot of people end up, because we're working on graphs this unit, a lot of people like using Pythagorean theorem better anyway, but these calculators you can put in your square root sign and type it in exactly the way you have it. So parentheses -1 minus 5 close parentheses squared plus parentheses 9 minus 1 close parentheses squared. Push enter and it finds the whole thing for you, which so the distance is 10. Alright, so we're going to take like 3 minutes for you to, in your groups, find the distance between these 2 points now. So do number 2. If your calculator manager didn't get calculators yet, then get it. So in this one, when we plugged it in, what did it come out as? 8.24 and 6.1. Okay, so I got lots of questions on what do we round it to. Okay, I should not hear any voices other than my own.
What?
I shouldn't hear any whispering or rustling around right now. And I need all eyes looking up at me. Okay, so here's the thing. Do you guys remember when we did distance earlier? So we did review this. We say we don't use decimal answers. We have to do simplified radicals. So anytime we have radicals like this, if it doesn't come out to a whole number, to get full credit, I did get partial credit for that, but to get full credit, you have to give me a simplified radical instead. So simplified radical, can I borrow someone who has this in your calculator? If you do it and you find it gives you a decimal answer, just copy the decimal. It'll copy the whole thing for you. Square it. It gives you a whole number of 68. So then we're going to write this instead as square root of 68. Okay? We aren't doing decimals. When we have square root of 68, can that simplify?
Oh God. No.
So we can go to 2 and 34. 2 and 17, right? So then the completely correct answer would be 2 root 17.
We have to do that.
So to get full credit, yes, you'll have to do this. If it's not a perfect square, you'll have to do the simplify steps. Okay. So I found in this unit, because anytime you're finding the distance, you'll also be graphing the points. A lot of people choose to use just Pythagorean theorem instead, which is the same thing, because when we subtract out the points, this becomes a squared plus b squared. And so on here, we're going to find the distance from these just from the graph instead of from the formula. So distance of AB, can I count that?
Yes.
Is that going to be a whole number if I just count it? Yeah, so 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. If you ever have a straight line straight along one of the axes or along one of the grid lines, you just count it. And D, 1, 2, 3, 4, 5, 6, 7, 8, 9. So CD is also 9. So I start out with the easy ones. What is the slope of those two lines?
1.
0. Remember, we're going straight like that, so our slope is 0. All right, for BC and AD, do you think those are parallel lines? They're going the same direction, right?
They are parallel.
All right, what's going on in the back? Okay, so what we're going to do is we're going to go ahead and count out our rise and our run. So 1, 2, 3, 4, 5, and our run is 1, 2. Okay, so if I'm counting, I just counted AD, my slope is 5 over 2. Those are the numbers I plug into my Pythagorean theorem. So I do my 5 squared plus 2 squared equals c squared to find my distance. And so that's 25 plus 4 equals c squared. And so my answer is 29 and then equals c squared. So what do I do to get rid of squared? Square root it. Does 29 square root, or do I leave it? Yeah, I can't simplify and then a decimal, so that's my answer. So the reason this is so much easier in this unit is if you already have things graphed and you already have to count out the slope, then we can easily just plug it in. This is also 2 and then 1, 2, 3, 4, 5. So rather than plugging the points into the formula, is this going to come out to that same slope? Because I have the same 2 and 5 to plug in, so that's also square root 29, and my slope is 5 over 2. Okay, so once you have that, flip over to the next page. So the next page, we're going to graph those 4 points, find slope and distance. How many people feel like you could graph it, find slope and distance without me helping at all? Okay, can you give me thumbs up, medium, down? Okay, so if you feel like you can do it on your own, you have permission to go ahead and work ahead. Just do it silently. And so I'm going to go through step by step for the people who need the review. So just a reminder, on a coordinate plane, this is my x-axis. This is my y-axis. And so for point L, all my coordinates go x, y. So I'm going to go -2. So from the center I go back 2, and then +3. So 1, 2, 3. That is my L coordinate. And then M is +4, +3. So that's M. N is +2, then -2, so down 2. And O is -4, -2. And then I connect them all to make my shape. Okay? So a part of your end of unit test that you're doing will be just like this, where you're given the points, you plot them out, you find slope and distance. And so to find slope and distance, I like to make myself a chart. And so I'm going to find one side is LM, one side is MN, NO, and OL. Am I going too fast, too slow, or the right speed? Good speed? Okay. So I'm going to call on people again. So if you're working ahead, just tell me the answer you already got. So LM, desk 30. Asa, what is the slope of LM?
LM. Slope, just like the coordinates.
No, just the slope. So rise over run, or 0 or undefined.
Oh, it's a 0, right?
0 slope. We got it.
Yes, sir.
All right. Next, I'm asking distance of LM. So desk 20. What's the distance of LM? 6. And we got that just by counting straight. So 1, 2, 3, 4, 5, 6. All right. Next, I have desk 25. So Chelsea, our rise over run, our slope for MN, what does that come out to? So if you just count, like along the grid.
5.
And then, so 5 and 2, and the rise goes on top. Is that a positive or negative line?
Negative.
Well, so if we come from here, are we going uphill or downhill? Okay, so it's positive. So always check. You can also say, are we counting forward or counting backwards, up or down? So now we're just going to plug those in to do our 2 squared plus 5 squared. This is the same we just did on the front. Equals 29. So our distance is root 29. All right, NO. I got desk 5, which is Peyton. What's our slope of NO? Well, look at it and look at the slope we've already found. So we either count rise over run or it's 0 or undefined. Yeah, it's 0. It's just the same as LM. All right, and desk 23 is empty. Do I have a volunteer for distance of NO?
Jordan.
6. Yep, we counted out same way. All right, desk 1. Kenya, slope of OL. For slope, so where we count out rise over run. So 6 was the rise?
Yeah, for right.
2, 3, I think it's only 5. So you're close. And then what's the run? 2. So it's the same 5 over 2. And then when we plug it in, it comes out to the same root 29. Okay, next class we're going to come back about how to write the proof statements to show that since we know the slope and distance, we can prove this is a parallelogram. So for right now, you guys are going to flip over to page 19 and do those 8 problems. So on page 19, it has part of it which is slope through points. You have 2 options if it gives you the points. You can graph the points and still count out rise over run, or you can plug it into the slope formula, which is, it's up on the board, it's also in your packet, but it's just y2 minus y1 over x2 minus x1. So the formulas are just letting you find with subtraction the same thing you find when you counted it out. So all we do here, we have again xy, xy. So we do 9 minus 2 and negative 5 minus negative 12. That becomes a plus sign, so this equals 7 over 5. So all you're doing is just plugging it into that formula. Anytime they give you points, you can either graph them and count it if you like that better, or you can plug them into the formula. If they give you a graph and you like the points better, you can always label the points and plug them into the formula. What's your question?
Like last year, like we could just plug 2 coordinates in, and it would like make make the line